Our first idea was to realize the interactive part by controlling the synthesizer with hand movement and gestures. We realized it by using a Kinect from Microsoft for the movement tracking and VVVV to process the data which we got from the Kinect. Because the Kinect is sending us all the data which it is measuring, we had to separate it to get only the coordinates from the left and right hand movement. After this we had to remap the data to MIDI nodes. We chose the horizontal movement for MIDI nodes and the vertical movement for the velocity. And to get a separation between left and right hand we split the MIDI nodes, so that the left hand could only play low notes and the right hand only high notes. After we tested this system we found out that this method would be not as accurate and probably not as reliable as we wanted to be. So we started to look for some new ideas how we can solve our little problem. After some days of hard considerations and discussions we found a new solution which should solve all our problems. We came to the idea to solve it with an Arduino board and piezoelectric discs. With our new solution, we are arranging the piezo discs in an 5x16 field for the sequencer and an 3x16 field for the drum machine. With the Arduino we will detect which disk was pressed and sending the MIDI node over a serial connection to a PC. Because the Arduino Mega 2560 we use has only 16 analog pins and we need 128 piezo disks to realize the sequencer and drum machine, we also need 16 multiplexer to connect the 128 piezo disks to our Arduino. After some weeks we changed the interactive part a little bit again. We replaced the piezo disks with conductive paint. The reason why we did this is because with the paint we were now able to draw our own fields and give the complete system a better look. At this point our system is nearly finished. We have to put the hardware into an oven and expand it by 4 knobs to control the effect settings.
The whole project is going to run on one PC. The visual and end parts created with Takdesigner. Takdesigner is a visual development platform that equips you with the tools you need to create stunning real-time projects and rich user experiences. As last part of this project, Takdesigner gets the MIDI from the Arduino board, which the user creates, and displays the visuals which are projected. We have the patch here which will be used for our project. I will show you the important parts of it. What you can see here is a MIDI in which currently is not connected to the Arduino, so it shows an error. I will still explain it. In this case we have 2 MIDI-ins which later will be at least 8. The number the MIDI node sending can be changed by this math node and can be taken from the null object and can be used. Up here is another example where I used 3 audio sources which represent 3 MIDI inputs. Our effect, which will be shown at the end of this presentation, is a little bit more difficult to explain. You can see a source which is changed by the noise to get this look. To get it to move around, I split the X and Y coordinate over here with a noise. The geometry here is colored by this constant, which gets its color from this null. To get this flashy effect we need a feedback, which is created by looping the render with a feedback node. You can see what you can do with Takdesigner. You can easily change more variables with the nulls you get from the median. At the end it's going to be visual eye candy.
So basically what we have here is the audio part of our installation. We are generating the sound in Ableton Live using a drum rack and a synthesizer. The synthesizer, as you can see here, is a Max for Lev patch and is a basic polyphonic synth. On top you see a few knobs controlling the cutoff frequency and the resonance. In this case it is labeled as gain of the filter and the IAS or envelope. Let's take a closer look at the data flow. On top we are receiving the MIDI notes from Ableton, which are being fed into this polytilt object, where the sound is being generated. Let's take a look at that. As you can see, the MIDI notes are getting unpacked and turned into a signal, which is fed into a sample and hold object. When the envelope trigger triggers the sample and hold object, the MIDI pitch is going to be converted into frequency by this MIDI to frequency object, which then feeds 8 oscillators, 4 of which are producing a sinusoidal wave and the other 4 are producing rectangle waves. As you may have noticed, all of the oscillators are slightly detuned to each other. to give the synth a bit of a warmer tone. Then all of the signals are being added together and clipped to the range of -1 to 1 to avoid distortion. At the end of the chain, the signal of the oscillators is being multiplied with the IAS envelope and sent out of the poly-tilt object. Back in the main patch of our polyphonic synth, the signal that comes out of the poly-tilt object is filtered by 2-pole filters, which are low-pass filters. The whole installation may sound something like this.
And look like this.